Welcome to Mrs. Z's Chemistry. In this video, we'll discuss measurement uncertainty and something called significant figures. Every measurement has some uncertainty that we usually describe as a plus or minus a 1 in the last place value digit that we estimated. For example, in this measurement of the graduated cylinder, the tick marks measure to the 1 milliliter, so we need to estimate to the tenths. When we say the measurement is 21.6, other people will understand that the last digit, the 6, was the estimated digit. Therefore, the accurate value is somewhere plus or minus 0.1 of that value, or between 21.5 and 21.7. Unit conversions are exact numbers. By definition, 1 inch is 2.54 centimeters exactly. In other words, 1 inch equals 2.540000, and so on and so forth, centimeters. Also, counted values are exact numbers. If you count 12 eggs, you know it's exactly 12.000 eggs. We're not wondering if it's somewhere between 11.9 and 12.1. If you counted it, you know you have exactly 12 eggs. The numbers of measured quantities, when you measure on a digital scale or graduated cylinder or a ruler or something like that, unlike defined or counted numbers, these are not exact numbers. All of the digits in a measured number, including the last estimated digit, are all considered significant figures or significant digits. Zeros may be part of the measured value and so considered significant. However, sometimes zeros are just placeholders and not part of the measured value. Therefore, they aren't considered significant. For example, if you step on a bathroom scale and it reads 128.0, we know that the digital scale estimated that last digit, that 0. So we know that the 0 is part of the measured value and therefore considered significant. If you were to place some food on a kitchen scale and it reads 0.04 ounces, we know this scale also estimated the last digit, the 4. However, the leading zeros here are just placeholders and they're not considered part of the measured value, and therefore they are not considered significant. We say this value then has only one significant figure, the 0.04. But this value over here has 4 significant figures. If you're looking at a number that you know is a measured number, here's a quick way to determine how many significant figures the number has. Essentially, it's determining whether the zeros are significant or not, and it's called the Atlantic-Pacific method. Imagine a map of the United States here. The Pacific Ocean is over here and the Atlantic Ocean is over here on the right-hand side. So if the decimal point is absent, A for absent, A for Atlantic, begin on the right side of the number and ignore all the 0 digits until you come to the first non-zero digit. And then that digit and the remaining digits going in that same direction are significant. If the decimal point is present, P for present, P for Pacific, begin on the left-hand side of the number and ignore all the 0 digits until you come to the first non-zero digit. That non-zero digit and all the remaining digits in that number going in the same direction are considered significant. And then, of course, the exact numbers, the counted numbers, have an infinite number of sig figs, and we don't count sig figs for them. So let's practice this with these examples. 234. The decimal place is absent. A for absent, A for Atlantic. We're going to start on the right-hand side of the number here, and we're going to skip all the zeros we first come to. Well, we don't have any zeros, so that means all of these numbers here, starting from the 4 as the first non-zero digit, on continuing in the same direction, are considered significant. So this value has 3 significant figures. Let's do the next one. Again, the decimal place is absent, A for absent, A for Atlantic. We're going to start on the right-hand side of the number. We're going to actually skip all of these zeros here, and the 7 is the first non-zero digit. So the 7 and everything else after going in that same direction are significant. Only the 6 and the 7 are significant here. The other 3 zeros are just placeholders. Of course, they're important for the value of the number. We still have 67,000. We just don't know. It might be 67,001 or might be only 66,980, something like that. We're not completely sure, but we know for sure of the 6 and the 7. We have 2 significant figures in this measured value. We have we're going to start on the right-hand side here. Skip this first 0. The 1 is the first non-zero digit. So this number and everything else after going in the same direction are also significant. So we've got 1, 2, 3, 4. We have 4 significant figures in this value. The 0 that is sandwiched between non-zero digits is going to be significant in every number. It's just the last trailing 0 that's not significant. Again, it's important for the value. We're still talking about 45,000 here. It just might be 45,011 or 45,009. We're not completely sure about that last digit. Now we come to a number with a decimal point. So P for present, the decimal point is present, therefore we're going to look on the Pacific side of the number, which is the left-hand side. We start on this side here. The 5 is the first non-zero digit we come to, so this number and everything else after is considered significant. We have 3 significant figures. I know this number looks funny with a decimal point without any digits to the right of the decimal point, but that decimal point, if you notice, changes the amount of significant figures. What it's saying is that last 0 is part of the measured value. It was the estimated digit, therefore it counts as significant. If you don't put the decimal point there and you just have 560, we would have to start on the Atlantic side or the right-hand side of the number. We would skip that first 0, and this 6 would be the first one we count. That would be measuring whatever we were measuring with a device that only measured to the tens here, and we had to estimate to the tens here rather than estimating the ones. So sometimes you'll see in chemistry or science, you'll see some numbers with a decimal point without anything after that decimal point, and that is to show you the precision of the measuring device that was used. Pause to see if you can work out the remaining 3 numbers, and then I will show you the answers. We have 4 significant figures here, the 5, and everything else after. So this last 0 is significant. It was the one that was estimated, but this first 0 is not significant. It's just a placeholder. All of these numbers are significant because the zeros are sandwiched between the non-zero digits, so we have a total of 5 sig figs here. And then in this last one, we're going to skip the leading zeros and you start with the 4. We only have 3 significant figures in this last value. When you take 2 measured numbers and use them in a calculation, either multiplying, dividing, adding, subtracting, not all the digits that your calculator just pops out are going to be significant. So there are a set of rules to follow depending on what calculations you did. Whether you actually multiplied or divided, there's a separate rule. Then there's a different rule for adding and subtracting. But for now, I'm just going to tell you to round to a certain number of significant figures, and then you need to know how to properly and appropriately round. So for example, I might tell you in the quiz or test problem, round the following numbers to 3 significant figures, or round your answers to 3 sig figs. So let's practice that. 308.60. So let's say you did some calculations in your for the chemistry problem. Your calculator popped out 308.60. Are they all significant? Well, maybe not. So I'm telling you to round it to 3 sig figs. So I'm saying only 3 significant figures are significant or important for the place for the measured value. So rounding to 3 sig figs, that's 308 point. Let's just rewrite this whole thing. The first 3 are right here. To preserve the value of the number, we use 308, and we're going to look at the next digit. Just the way you would normally round in math, if the digit is 5 or greater, you round up. So since we're looking at a 6 here, our rounded number is 309. This is actually the most accurate that we can represent our answer of 308.60. This is not more accurate. We don't know the measuring device that was used, and this is as accurate as we can show our answer, 309. Pause the video and try the rest on your own before seeing the answers. So here are the answers. In order to write 100 or 3 significant figures, we just need to place a decimal point at the end. But don't add any more zeros, because now we're going to, since the decimal place is present, we start on the Pacific side of the number, which is over here. The first number we come to is a 1, and it's a non-zero digit, so that 1 and everything else after, including these 2 zeros, are significant. Without the decimal point, like the way it's written here, you'd have to start on the right-hand side and skip those zeros, and you've only got a 1. So the way it's written here, we have 1 significant figure. The way it's written here, we have 3 significant figures. That decimal point is saying this 0 right here was the one that was measured, or the one that was estimated in our measured value. All right, for 3 significant figures, we have 1, 2, 3. We're going to look at the next digit. The 8 is going to round the 9 up, which then, of course, has to round the 5, but you have to include this 0 here. At the end, 1.50 is 3 sig figs. Just 1.5 is only 2 sig figs. 4.249, we have 1, 2, 3 digits. So we're going to round the 9, or the 9 here rounds the 4 up to 4.25. Now, in order to write 1 million with 3 significant figures, the only way to do it is writing it in scientific notation. So with scientific notation, the times 10 to the exponent here do not count towards significant figures. Only the decimal number, the 1.00, is counted as sig figs. So for example, 3.29 times 10 to the 3 has only 3 significant figures, and that's the 3.29. So we would write 1.00 times 10 to the 6, and that gives us the value of 1 million, and we're saying we know that up to 3 significant digits, the first 3 digits of the million, are exactly 1.00. We're maybe not sure about the other ones, but the value is 1 million. Speaking of which, we can go back up to here actually, and write the 100 like this. We would have 1.00, there's your 3 sig figs with the decimal point there, and then times 10 to the 2, that gives us 100 with 3 significant figures, as well as writing it like this. When a chemistry problem involves multiple calculations, don't ever round the number until the very end. So for example, 3 different students measured the mass of an object in grams. Their values were 3.48, 3.52, and 3.44. What is the average value? And then round the answer to 3 sig figs. So if we were to work out this problem here, we would see that the total, 3.48 plus 3.52 plus 3.44, your calculator gives you 10.44. Don't round until the very end, as that is the rule for science problems here. So then, in order to find the average, you divide by 3, because there are exactly 3 digits, or 3 values, 1, 2, 3. And then when we plug this into our calculator, we get 3.48. This is the answer. That's the average value to the correct number of significant figures. But if we were to round the first value, the 10.44, if we were to round it to just 3 sig figs and write 10.4, then divide by 3, we would get 3.4666 repeating, and then with a 7 in the last digit there. So then this would technically round, here's your 3 significant figures, look at the 6, it would round up, so it would round to 3.47 as your answer. And while that does seem very close to the actual answer of 3.48, if in some real world or real life problems, this actually does make a difference, and especially when a lot of chemistry problems involve lots of calculations. If you were to continuously round after every single calculation, you often end up with a pretty big difference. So keep to the rule. Don't ever round the number until the very end of the problem when you're completely done. Then go back and look at how many sig figs are you supposed to have, and finally, for the first time, round your number.